Hello, I am Ahmed Amrani. I am a research engineer at the IRT SystemX Institute, which is located in Paris region, France. The institute contributes to accelerate the digital transformation of industry, services, and territories. I am going to present the paper entitled Digital Twin Approach for Sustainable Territories Planning, a case study on district heating. This work is carried out as part of the PSE project, Paris-Saclay Energies project, with the collaboration of the administrative entity Paris-Saclay Urban Community and Cosmotech, which is a company dedicated to digital twins and simulation softwares. The sustainable energy planning process in the city is a very complex task that involves several stakeholders and requires the consideration of several local and global factors and constraints. In order to optimize and simplify this process, we propose a decision-making application applied to district heating planning. The application leverages large and heterogeneous data of the city. The application supports the design of energy planning strategies. The application leverages digital twins in order to evaluate the proposed energy planning scenarios. This slide presents the global energy planning process, which is composed of 5 steps. The first step consists of collecting and pre-processing relevant data to support energy planning process. The application lets us to visualize and analyze the collected data. In the second step, the energy potential of the city is visualized and evaluated. Then, the application lets us to identify the area of interest by selecting a polygon on the map. The contextual information related to the selected area are then computed and displayed by the application. The fourth step consists of the design of energy planning scenarios for the selected area. Finally, by using digital twin, the candidate scenarios are evaluated and compared. This slide presents the data sets exploited and displayed by the application. The data are organized in 4 sections: territorial information, existing energy networks, the estimated energy consumption, and the potential of renewable energies. The displayed map presents the land parcel information and the heat network route. This slide presents the potential of renewable energy of the city. The first map presents the potential of geothermal energy. In the Paris region, there are several layers of geothermal energy. Each layer is characterized by a depth and a temperature. The figure presents the variation of the potential of the Dogger layer depending on the localization. The second map presents the solar energy potential of the roofs, which is obtained thanks to the regional agency Energy Climate of the Paris Region Institute. In this step, the application allows to select the area concerned by the planning operation. Once the area is selected, the application displays contextual information related with the area. For example, the distribution of building by energy class, the distribution of consumption by energy class, and also the distribution of greenhouse gas emission by energy class. Various information about the building located in the selected area are also displayed, such as the number of floors and the years of construction. Now we present the step concerning the design of planning scenarios. In the context of urban networks, the application proposes the following scenarios: creation and extension of heat networks, and building renovation. To facilitate the extension and the comparison of the scenarios are organized in hierarchical tree structure. As shown in the figure below, the application allows you to add heat production sources and connect them to an existing heat network. Several parameters are configurable, such as the investment cost and the type of heat source, for example, geothermal or gas. This slide presents the scenario evaluation step. Once the scenario is designed, the evaluation process can start. The application evaluates each scenario using a digital twin technology. As presented in the figure on the top, for each scenario, the digital twin computes several KPIs related to the consumer's satisfaction, economic, and environmental characteristics. As presented in the figures on the bottom, the application allows also to compare the candidate scenarios. For example, geothermal production compared to the biomass production. Now we present the global architecture of our application. At the core of our decision support system, we use digital twin technology. The Azure Digital Twins platform is used to create a digital representation of the city's physical environment, and the Cosmotech platform allows to perform a simulation. The data are stored in a multimodal database, Azure Cosmos DB. We use React as a front-end framework and Power BI to create the dashboards used for representing the results of the simulation. Given the complexity of energy planning in urban environment, we have proposed a tool-based iterative approach which is organized in several steps. Data analysis and visualization, selection of the area, design of sustainable energy planning scenarios, and the evaluation of candidate scenarios. The last step is performed using digital twin technology. The proposed approach was applied to district heating. Our perspectives are, first, to include data-driven optimization approach to select the best scenario based on several criteria, and to adapt our approach for different cities and other sustainable planning use cases. Thank you for your attention.